A'udhu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear students of 12th class subject Botany, Assalamu alaikum wa rahmatullahi wa barakatuhu. Dear students, today on 10th of July 2021, our topic is Mendels dihybrid cross. Before our today's topic Mendels dihybrid cross, we have discussed the Mendels monohybrid cross in our yesterday's lecture. So, our today's topic is Mendels dihybrid cross. Dear students, we have seen that a breeding experiment dealing with a single character is called a monohybrid cross, while as a breeding experiment dealing with two characters at the same time is called a dihybrid cross. So monohybrid cross relates to the single character, while as a breeding experiment dealing with two characters at the same time is called a dihybrid cross. In one such experiment, Mendel considered two characters. One was the form of seeds and another was the color of cotyledons. So in one such experiment, Mendel considered form of seeds and color of cotyledons. Then what he does? He crossed a pea plant having round seeds and yellow cotyledons with another pea plant having wrinkled seeds and green cotyledons. So dear students, you should remember that two pea plants were considered. One was having this form of seeds and color of cotyledons, and one was having the round seeds and yellow cotyledons, while as another was having the wrinkled seeds and green cotyledons. So there was a vast difference. So these two pea plants having two different characters were crossed with each other. So what the Mendel does? He crossed a pea plant having round seeds and yellow cotyledons with a pea plant having wrinkled seeds and green cotyledons. So what was the result? All the plants in F1 generation were having round seeds and yellow cotyledons. So in the F1 generation, the character of the first plant which has the round seeds and the yellow cotyledons was dominant over the this another pea plant which has the wrinkled seeds and green cotyledons. So in F1 generation, all the plants were having round seeds and yellow cotyledons. These F1 plants which have the round seeds and yellow cotyledons on self-pollination produced four types of plants in F2 generation. So when these F1 plants were self-pollinated, they produced four types of plants in F2 generation, thus giving a ratio of 9:3:3:1. So what is this 9:3:3:1? It is round seeds and yellow cotyledons were 9, round seeds and green cotyledons were 3, wrinkled seeds and yellow cotyledons were 3 plants, while as wrinkled seeds and green cotyledons were 1. And in this way, the distribution was made 9:3:3:1. The distribution, the ratio was distributed into these 9 plants, then 3, and then 1 plant. So the round seeds and yellow cotyledons were 9, round seeds and green cotyledons were 3, wrinkled seeds and yellow cotyledons were 3, and wrinkled seeds and green cotyledons were 1. Thus, a dihybrid cross produced 9 plants of dominant trait. So a dihybrid cross thus produced 9 plants of dominant trait, 1 plant of recessive trait, and 6 plants of mixed trait. So a dihybrid cross thus produced 9 plants of dominant trait, 1 plant of recessive trait, and 6 plants of mixed trait. So new combinations appeared in dihybrid cross. So dear students, this was a short question, Mendel's dihybrid cross, and you have seen that we have defined this dihybrid cross and experimentally uh, how the Mendel explained this dihybrid cross. We have thrown light upon this. So in this way, we have concluded, we have completed our today's topic. Now, in our next lecture tomorrow, we will move towards one more question of this unit second. So, stay home, stay safe. Thank you very much.